The formula here models the population of a state in millions, t years after the year 2000. So the first question is asking, what was the population of the state in the year 2000? So if t is the number of years after 2000, that would mean that 2001 is 1 year after 2000. T would equal 1. And if 2002 is 2 years after 2000, t would equal 2, right? What would the year 2000 be? What would t be? T would be 0. So the year 2000 is actually 0 years after the year 2000. So for part A, what we have to know is that t is going to equal 0. And if we know that, we just plug it into the formula right there. So let's go ahead and write down the formula. A equals 15.7 e, Euler's number there, to the power of 0.0429 times t. And what's t going to be? 0. So we know that anything times 0 is just 0. So that's going to give us e to the 0. A equals 15.7 times e to the 0. Anything to the power of 0 is just 1. So A equals 15.7 times 1. Anything times 1 is itself. Okay, so this makes sense that the population is 15.7, and that's in millions. And that's where we started. So that's the answer for the first part. 15.7 million. Million. Let's say million. 15.7 million. Part B. Part B says the population of the state, when will the population of the state reach 18.7 million? So we're trying to find out when A is 18.7. And we're going to write the formula down again, and we're going to take 18.7 and we're going to plug it in right there for A. So we're going from 15.7 to 18.7. All right, let me move this over to the right-hand side. Whoops. Do a little technology, internet magic here. I'll put it over here. Nice. Okay. Let's go ahead and rewrite the equation. The equation is A equals 15.7 times e to the power of 0.0429 t. All right, now I know that A is 18.7. I'm going to plug that in right here. So I'm plugging in for A 18.7. And now we have an equation, and we need to solve for t. So I'm only looking at this part right here. Now t is up in that exponent. We want to get it out of that exponent. First thing we're going to start doing to get t by itself, let's go ahead and divide out this 15.7 from both sides. I'll divide this side by 15.7. I'll divide this side by 15.7. And now we're going to get 18.7 over 15.7 equals, those reduce down to a 1, so equals e to the power of 0.0429 t. All right, now we want to get this t out from the exponent. So to get it out from the exponent, one way you could do it is you could look at this logarithm to exponent property. But what we're going to do is we are going to take the natural log of both sides. Okay, let me move this equal sign over to the left a little bit. So at this point, I'm going to take the natural log of the left side, and I'm going to take the natural log of the right side. Now why did I do that? Because I know that the natural log of e to a power is just that power. Okay, it's going to bring it back down to earth. So the left side now is natural log of 18.7 over 15.7 equals, and the right hand side is now just a big 0.0429 t. Now the t is back down to earth. It's not part of an exponent. Only one more step to get that t by itself. We are going to divide both sides by 0.0429. So those reduce down to 1. This side divided by 0.0429. And that's what t is going to equal. T is going to equal the natural log of 18.7 divided by 15.7 over 0.0429. That's what t equals. Now, they're asking us to round down to the nearest year. They want us to find a year. They want us to round it down. So let's go ahead. Let's grab your calculator. Let's put all of this in the calculator. Okay, I have my calculator here. The natural log, ln, of 18.7 divided by 15.7. Make sure to close the parentheses. I'm going to hit equals. That gives me 0.174862812 divided by 0.0429 equals, and it gives me 4.076, and it goes on for quite a while. So it equals 4.076. All right. Now it says round to the nearest year. Well, if they want the year, I'm not going to tell them 4. What t represents, remember from the original problem, t is the number of years after 2000. So this is 4.076 years after 2000. So my answer for part B is going to be 2004. Okay, round down to the nearest year. I haven't reached 2005 yet, so my answer for part B is 2004.